Today, we're going to learn how to solve a system of equations with two different methods of algebra. The first one we're going to learn is called substitution. That's where we take one equation and substitute what it equals into the other equation. The reason we have to do this is because we can't solve one equation that has two variables. We have to get it down to one variable. So looking at these two equations, we see that we have a y with no coefficient in front of it in this equation. So what we're going to do is take the 2x and move it to the other side. That means that y equals 11 minus 2x. Now, since we know what y equals, we can take this part and substitute it into this second equation in place of y. That will get rid of the y. So looking at that, we have 6x minus 2 times y, so it's going to be 2 times everything that we moved to the other equation, 11 minus 2x, and that equals negative 2. The next thing we need to do to solve this equation is the distributive property. That means that minus 2 is going to multiply by 11 and negative 2x. So that gives us 6x, negative 2 times 11 is negative 22, and minus 2 times minus 2x is positive 4x. The next thing we need to do is combine matching terms. We have two things with an x. So 6x plus 4x equals 10x. And we move everything else down. Next, we need to take the minus 22, move it to the other side and make it positive. That gives us 10x. If we add 22 to that, that makes 20. 10x equals 20. Then divide both sides by 10, and that gives us x equals 2. Now that's one part. The second part is we have to plug the number 2 back in to any equation that has an x and y. The easiest one is what we solved over here on the left side. So we'll take our y equals 11 minus 2x, and we'll put our x number, which is 2, in place. So now working that out, negative 2 times 2 is minus 4, and 11 minus 4 is 7. So now we have our y number. Written as an ordered pair, that would be 2, 7. And that's your final answer. Okay, let's move down to this system of equations. Over here, we have a y with no coefficient in front of it, but it does have a negative sign. So we're going to isolate this. The first thing is we have a positive 8. When we move it over to the other side, that will be a negative 8. So it's 2x minus 8 equals negative y. Now, since we have a negative y, we can change the sign of everything in the equation. That actually multiplies the equation by negative 1. So that means that y equals negative 2x plus 8. So we're going to take this entire side, since we now know that that equals y, and we're going to substitute it into the first equation. So taking that, we now have 6x plus 3 times everything inside minus 2x plus 8 equals 12. To solve this equation, we need to use the distributive property again. And so now we're going to have 6x. 3 times negative 2x is negative 6x, and 3 times 8 is 24, and that equals 12. Now you see we're going to run into a little bit of a problem. 6x minus 6x is 0. That means that entire thing goes away. And what that leaves us with is 24 equals 12. That statement is false. There will be some systems where all the variables fall out of the equation. If you're left with a false statement, that means there is no solution. If you end up with a true statement, for instance, if it said 12 equals 12 or 0 equals 0, the true statement would mean that the answer is all real numbers, meaning there are infinite solutions. So watch out for that, because there's a few problems on the work that involve this. All right, let's learn the second method, which is called elimination. The idea here is that we have to make either x or y fall out of the equation. We can add these two equations together. If we were to do that right here, we would end up with 3x plus 2y equals 18. But what we can do in this situation is change the signs on one of the equation. We can do that to the bottom equation. It doesn't matter which one. So we're going to change all of these to negatives, and then we're going to combine them or add them straight down. This is 1x minus 2x, which is negative 1x. We can just put negative x. Y minus y cancels out, which is the whole point. 7 and negative 11 make negative 4. So now we have minus x equals minus 4. We can change the signs of both of those. That's multiplying by negative 1. And so we have that x equals 4. Just like in the other equations, we're going to plug 4 back in to any equation that has an x and a y. I'm going to choose the top equation because it looks the easiest. Remember, that was x plus y equals 7. And so we replace the x with 4. And that means 4 plus y equals 7. Meaning that y equals 3, because 4 plus 3 equals 7. Written as an ordered pair, it would be 4, 3. We're going to look at a few more examples of elimination. Now looking at this, we can't combine them yet because we don't have matching numbers with opposite signs. For instance, we have x and 7x, that would make 8x. We have negative y and 2y, which would just give us positive y. Nothing falls out of the equation. What we can do, though, is multiply everything in an equation by any number we want to, as long as we multiply it or divide it by the same number. So we're going to take this entire top equation and multiply everything on the top by 2, because that will give us minus 2y, which will be opposite of positive 2y. So what we get here is x times 2 is 2x. Remember, we're multiplying 2 times every single piece of this. So we have x times 2 is 2x, minus y times 2 is minus 2y, and minus 9 times 2 is minus 18. That will help the y's fall out, so we don't need to do anything to the bottom equation, except just move it over. Now when we add them together or combine them, 2x plus 7x is 9x. The y's go away. And negative 18 minus 9 is negative 9. Dividing both sides by 9, we get x equals negative 1. Now we can take that negative 1 and plug it into any equation. The top equation here on the left is the easiest one. So we're going to replace the x with negative 1 minus y equals minus 9. We're going to take this minus 1, move it to the other side, and make it positive. So now we have minus y equals negative 9 plus 1 is negative 8. Since we have a negative in front of our variable, we'll just change the sign of both of them, and that means y equals 8. So our ordered pair is negative 1, positive 8, and that's the solution to that set of equations. Looking at this example, there's no whole number we can multiply 2 by to get to 3, and there's no whole number we can multiply 4 by to get to 5. So what we can do in this instance to avoid fractions and decimals is multiply the top equation by 2 and the bottom equation by 3. I could have just as easily multiplied the top by 4 and the bottom by 5, and that would make the y's fall out. So multiplying everything in the top equation by 2, we get 3x times 2 is 6x, minus 5y times 2 is minus 10y, and 6 times 2 is 12. On the bottom equation, 2x times 3 is 6x, negative 4y times 3 is negative 12y, and 4 times 3 is 12. Now this still won't make everything fall out because the 6x and the 6x are not opposite signs. So we're going to change the sign of the bottom equations. What you could have also done is multiplied everything by -3, or multiplied the top by -2 and the bottom by +3. Now this will make the x's go away. So looking at the y's, we have -10 and +12. That makes +2y. And 12 minus 12 is 0. Dividing by 2, y equals 0. And just like our other equations, we're going to take our 0 and plug it in to any equation we want. So I'm going to choose this bottom equation. 2x minus 4 times 0 in place of y equals 4. So working that out, 2x minus 0 equals 4. That's a step you can skip if you see it. And now we divide both sides by 2. That means x equals 2. So our ordered pair is 2, 0. So just keep in mind that as long as you do the same thing inside that one equation, you will get an equal value. So let's move down to our word problem example. Last year, a volleyball... I'm gonna read it! Okay, fine, whatever. God, he's been driving. This is my imaginary son, Jehudi. He's gonna read the rest for us, if he can. I can't. Last year, a volleyball team paid $5 per pair of socks. They were bedazzled. And $17 per pair for shorts on a total purchase of $315. Good Lord, that's a lot of money. This year, they spent $342 to buy the same number of pairs of socks and shorts because the socks cost $6 a pair and the shorts cost $18 a pair. Good Lord have mercy. How many pairs of socks and shorts did the team buy this year? Okay, go play somewhere while I fit. No, get over there. God, he's driving me nuts. Okay. Now, if we tried to write a set of equations for this, it would look something like this. Now, I couldn't use S for socks and shorts, but I can use whatever variable I want. I could use X and Y. It would look like this. For last year, it's $5 for each pair of shorts. We'll call that X. And $17 per pair of shorts. We'll call that Y. So plus 17Y. That equals a total cost of $315. For this year, it was $6 for the socks and $18 for the shorts, and that cost them $342. Now, if we were to solve this, we would need to do something like a multiplying the top equation by 6 and multiplying the bottom equation by 5 or -5. And you can see that this would lead to some problems, and you'd have to do a lot of calculator work. So instead of solving that like I did the other ones, I want to show you a test-taking strategy that you can use. You have the answer choices over here on the left. I think Jehudi wrote the last one. But what we can do on something like the ACT is take these answers and see which one works out. Remember, we're trying to figure out how many they buy this year. So let's start with choice A. It's 11 pairs of socks that cost $6 a piece. That's $66. They buy 13 pairs of shorts that cost $18 each. 13 times 18 is 234. No, I didn't automatically know that. Adding those two together, we get $300. So we know it's not A. Let's look at the second one. 12 pairs of socks at $6 a piece is $72. 15 pairs of socks at $18 a piece is the same as 30 times 9 if I double the 15 and cut the 18 in half. So that makes 270. Adding those two together, we get $342. So that means that they bought 12 pairs of socks and 15 pairs of shorts, and our answer is B. Remember to send me an email if you're having trouble with any of the work. Hope you have a great day, and I'll see you next time.